Hello once again. In this lecture, we will see another parameter of a rectifier. See, I didn't say that I'm showing you another parameter for half wave rectifier or center type rectifier or bridge rectifier. This is the parameter that I'm going to show you will be applicable for all those rectifiers, is it? It is the common one. Whenever we start with the practical session, this parameter plays very important role, is it? To calculate the stability of a rectifier, stability of a circuit that you have mounted on your breadboard, is it? So this parameter is nothing but your regulation. Let me write it as regulation. Now regulation is defined as, I will write capital R notation, it is defined as VNL minus VFL. I will tell you what is VNL and VFL. For the time being, I'm just writing equation VNL minus VFL divided by VFL. That is what. Now, what is that VNL? Let me elaborate here. VNL means voltage at no load. Generally, whenever I say voltage at no load, people think, or my students, they think about voltage at no load resistance. No, the resistance part is not there at all, is it? It is there, but indirectly. The load means basically a current. In electronics, whenever you say it's a load, it means I'm talking about the current, is it? If we think about this room, then the fan, the tube, all are acting as a load. Load means basically what? Conceptually, load is anything that takes current from your circuit, anything that need a current to operate, is it? For example, if I have an amplifier, look at this, for I have an amplifier and I'm going to connect a motor at the output of this amplifier, then that motor will be a load for the amplifier. Instead, don't connect motor, connect a fan. The fan will be the load for the amplifier. If I connect a bulb, then bulb will be the load for the amplifier, is it? Why? Because bulb is taking current from the amplifier to glow, fan is taking current from the amplifier, is it? So everything that you connect at the output and which consumes some current is a load, is it? So VNL means basically, let me write it in clear words as VNL means voltage when there is no load current. See, voltage when there is no load current. Load currents generally we write it as an IL. So as if there is no load current means IL is equals to 0, or I can say minimum, right? And when current will be 0, generally when current is 0, current becomes 0 when resistance, that is load resistance, becomes infinite, or I can say maximum. Obviously, when resistance is maximum, current becomes 0. There is no current when maximum resistance is there. That this is a voltage when there is no load current at all. That is IL is equals to 0 when RL is infinite. Right? For example, if I have rectifier, take an example of half wave rectifier, the simplest one to draw here and to understand. Look at this half wave rectifier I'm drawing. This is a diode, and now here load has to be connected. See, all the time I'm showing a resistor just to analyze it, just to analyze the circuit. It's not that you have to connect resistor as a load all the time. You can connect any other component device, is it? It's on wish. Now what I want to measure voltage when there is no load current. So as if there is no load current means IL must be 0. To make IL 0, RL, that is resistance between this terminal and this terminal, must be infinite. So as if resistance must be infinite, it means it must be open circuited. That's what it is now. There is no connection between these 2 points, it means the resistance exists between these 2 points is infinite. So RL is infinite. That's what VNL. Now measure voltage between these 2 points by using a multimeter, and whatever multimeter shows is whatever VNL, voltage when there is no load current at all. Is it? That is the concept of VNL. Now if we consider full wave rectifier, or consider half wave rectifier itself, as we have done half wave rectifier, when you don't connect any resistor, then what will be the output voltage? A DC voltage which is available is equals to what? We have already calculated, it is Vm by pi. So Vm by pi is VNL for half wave rectifier. Is it not? That's what it is. Now let's check what is VFL. VFL, here also I will write in clear language. VFL is voltage when there is full load current. Voltage when there is full load current. Load current is maximum, that is I will write IL will be maximum, or IL will be infinite ideally. That must be maximum. And when current will be infinite? Obviously when there is load resistance becomes zero, or I can say minimum. Yes, it is an obvious. When resistance is zero, current will be maximum. Is it? Now take the same example. Take an example of half wave rectifier itself. Let me draw the rectifier again. Now look at this. One diode is connected, and in between these two terminals, now I have to connect a resistor which has zero value. Yes, it is. The resistance which has zero value is means as good as I have to make them short, and that's all. Is it? See, I have connected two output terminals of a circuit, but practically this is not allowed. We cannot short circuit two output terminals of any circuit. Obviously if I connect it anyhow, just if someone want to see what will happen if I connect two output terminals, then as if I connect two output terminals, then excess current will flow through the diode. Look at this, excess current will flow through the diode, and this diode may get damaged, can happen. So that's why connecting two output terminals or making short circuit between two output terminals, practically it is not feasible. Is it? So as if practically it is not feasible, then what is the alternative? We need to find some alternative, because I want to measure, anyhow I want to measure this VFL. Then practically, this is what the theoretically VFL means, it must be a short circuit. But practically if you want to measure VFL, then what do? You connect a small resistance. Okay, let me take a blue pen as it was. Practically you connect a small resistance, and then this small resistance can be of 100 ohm, or you can take 80 ohm, 91 ohm, anywhere it must be small. I'm just preventing a short circuit. That's what it is. The resistor that I have connected is or has to prevent the short circuit. It should not get short circuit, and that's what the job of resistor. Is it? Practically that's what I have to do. Ideally or theoretically it must be zero. Two terminals should be short circuited. Is it? Now practically, as if I have connected this resistor, now measure this. This is what my no load full load condition now. Is it? There is a resistor, but for me the resistor is not there. Is it? Now you have to measure the voltage between these two terminals by connecting a multimeter. This is what multimeter. If you connect multimeter, and whatever multimeter shows is what your VFL. At the time of practical, for all these rectifiers you have to measure VNL and VFL, and whatever value of VNL and VFL you measure, put this value in the final equation, that is VNL minus VFL divided by VFL, and calculate regulation. Now if I want to represent regulation in percent, then whatever you have multiplied by 100, that will be percentage regulation. Is it? Before that we have seen what is ripple factor, amount of AC components present. Now what regulation shows? Regulation shows the stability of a circuit. Is it? As if VNL, that is voltage Vn, no load current is there, it is Vm by pi for half wave rectifier. Is it? Now for this half wave rectifier, how to find out this voltage, that is VFL? That VFL will be, then look at this, how much current is flowing through this small resistor multiply by the value of resistor. If I am treating it as an RL, then I will write IDC multiply by RL. This is what? Regulation, IDC multiply by RL. Yes, VFL, IDC, RL, VNL, Vm by pi. Is it the ideal condition that I have considered? One VFL, I need to consider a practical condition, and then I am getting a regulation factor or percent regulation. Is it? The ripple factor that we have seen, the ripple factor value should be very less. It must be less because amount of AC component present in the output must be less. Like this, a regulation, the percentage regulation, that figure has to be very small value. It should be very less. If the regulation figure is less, it means the performance of your rectifier is better. Is it? The performance is better, and generally what we expect, regulation must be very small. It means the fluctuation, the change in output voltage must be very small. If I want to draw a figure, if I want to draw a graph, then this is what ideal thing that we expect. Is it? It means output voltage must be constant. Anyhow output voltage must be constant. But what happened? Because of some reason, this output voltage goes on decreasing. Is it? So this is what change in the output voltage. That change should be very small. Change should be very small. Then only your rectifier is giving its best performance. Is it? So this is about regulation. For all the rectifiers, the concept of regulation will remain same. The equation VNL minus VFL divided by VFL will remain same for half wave or full wave and even for bridge rectifiers. Is that? So this is all about regulation, and we have to calculate or we have to measure this regulation at the time of practical of half wave, full wave, and even practical for bridge rectifiers. Is that? So from next lecture we will start with some other parameters. Then thank you.